Good morning and good afternoon. Welcome to the presentation by ARDANUY Engineering about Allplan Bridge, entitled Allplan Bridge, a comprehensive study of bridge design solution. We are going to provide you with some insight into the various design solutions offered by Allplan Bridge.
First, let me introduce today's agenda. We will start with an introduction to our presenters. Next, we will provide some insight into our firm, followed by an in-depth analysis of 3 case studies. These case studies include a railway bridge, the Albarrega Viaduct, and some cases of superstructure, both railway and highway. Finally, we will draw some conclusions based on this topic. As I said, let's introduce ourselves. I am Jorge Serna Lozano and my colleague is Jonathan Norato. I have a bachelor's degree in architecture from the University of Alcalá, Spain, as well as a master's degree in building information modeling from the Polytechnic University of Madrid, with more than 3 years of experience as a MIP manager. Jonathan Norato, on the other hand, holds a degree in civil engineering from the University of the Andes, from Colombia, and has more than 3 years of experience as a BIM coordinator at the ARDANUY engineering firm. Before we dive into the specifics of Allplan Bridge, let me provide you with a brief overview of ARDANUY Ingenieria. ARDANUY is a multinational company that specializes in providing innovative solutions to the transportation engineering sector, with over 8 years of experience in the BIM methodology. ARDANUY has become a leading name in the industry. The company currently employs over 400 professionals who use this methodology, including more than 30 specialists in BIM topics such as civil engineering, hydraulic engineering, architecture, and other relevant disciplines. ARDANUY's offices are located in different parts of the world, including Spain, Colombia, India, Brazil, and Lithuania. Well, now we will be presenting 3 case studies. The first case study will focus on the Albarregas Viaduct, which features 2 symmetrical through beams. The second case study will highlight a railway bridge with multiple railway lines. Finally, we will explore practical cases of both road and railway bridges in the generation of superstructure. Now, my colleague Jonathan is going to start with the first case study.
Thank you, Jorge, for your informative and engaging introduction. As mentioned earlier, my name is Jonathan Norato, and I will be presenting the first study case. We will begin with the Albarregas Viaduct, located in Mérida, Spain. This railway bridge spans 169 meters and features 6 double T in U girder arranged in 6 spans. The arrangement is shown on screen. The new bridge is isostatic and has prefabricated through girders that are 5 meters apart from each other. On the lower right corner of the screen, it is displayed the current bridge. However, a new proposal will be made to meet the new speed design requirement. To generate the design proposal for the Albarregas Viaduct using Allplan Bridge, we employed a range of tools and features. These include smart symbols for bridge support placement, link girders for through-beam modeling, the use of parametrical variables with tabulation of table, and the hunch of the deck, which allows for Boolean operations. As the first step in our design process for the Albarregas Viaduct, we took the axis definition, which were in land XML format. Using this format, we were able to create an accurate representation of the bridge layout in both plan and elevation, including ground level, section, and the location of support, bearings, abutments, and other structural elements. This layout serves as the foundation for the rest of the design process. We use a range of tools and features which allow us to accurately define the axis for the bridge. Once defined, these axes were exported to an XML format and then imported into the BIM Plus portal. After exporting the definition of the axes, they were imported into BIM Plus portal. Here, we were able to work with different versions of the design and the tracks of the axis as the project progresses. As you can see on the screen, we are currently on the version 5. Also here, I have a video of Allplan Bridge. Here we can see all the axes. As you can see, there is the axis of the bridge, and also there are axes perpendicular to the bridge that are served to the link girders. And here we have the alignment is in version 3, and you can see the axis plan and also the profile as shown on screen. Another tool that was used in the design of the Albarregas viaduct was the smart symbols, specifically for the bearing pod support. The pod support was inserted as a smart symbol using a cross section for the points located on the right. There is a reference, the reference point, that allow us to choose the location of the smart symbol. In this case, the section considered was perpendicular to the bridge axis. Here I will show how this was done. You can see the cross section on the left side, also how let's say the link girder was placed. And when we scroll down and we go to reference point right, we can see the smart symbol placement on the right side of the screen. We use also the parametrical variables linked to tables. The use of tabulation and tables allows for the automatic generation of the different lengths of the beams, with the corresponding dimension being adjusted automatically. Additionally, the haunch of the deck was used for Boolean operation, allowing for the generation of the required shape for the bridge deck. We use different types of stationings. Some examples are relative as well as local and local in definition. The relative stationing is used when there are reference points that could change and the geometry adapts to these relative values, let's say. On the other hand, the local and local in definition type are useful when there is a fixed measure or spacing between model elements. Another key aspect of the project was the implementation of link girders and Boolean operation. This allows for the generation of all the necessary beams with a specific name convention consisting of both letters and numbers, as you can see on the screen. Additionally, the team decided to spawn the haunch on the left, middle, and right sides to ensure accuracy and precision in the design. I will show an example on the next slide. So in the following example, we can see how the haunch is created in order to fill the additional concrete required to feed the deck with the beams. In addition to the previous function, stationing was also generated to provide a gap between the middle of the section, resulting in the solidification of only the parts near the support, while the rest remains normal as demonstrated on the screen. So here I can see the gap and the two sections that were used. On the left hand side, we can see the 3D model generated in Allplan Bridge, while on the right hand side, we see the cross section of the pedestals. Finally, on the lower right hand side, we can observe the symmetrical beams. Another crucial factor was the DWG export of the bridge, as it was a requirement of the client. So after generating it in Allplan bridge and passing it through Allplan, it allows us to export both the beams and the remaining components of the plant as shown in this image. Additionally, an isometric view of the entire bridge was also exported as a final output. This is the final result exported to EFC format. Here you can see the previously mentioned structure of the viaduct.
Thank you, Jonathan. Let's continue with the second case study. This case is a railway bridge. It's a portal frame. It's made up of a total length of 12 meters. It also has a variable deck and transversal slope. On the screen is presented the width of the bridge, considering the side track, main track, and parapet. In this railway bridge project, the cross-section is a challenge, due to each element having its own dimension and axis, as seen in the elevation as we will show. This cross-section can be directly taken from Allplan engineering. We will show how it was modeled. We are going to present a different modeling approach to previous case. In this case, we use a reference axis, as you can see on the screen, and then we have respective axes to some key points. Here we have 1, 2 axes, and there is another axis that was really important to the same process. We model the bridge using the reference axis as a base. Then, with the parametric point in Allplan bridge, we attach each point to an axis, which later was attached this expression of type formula to reference this axis, with the let's say master of ground axis, as you can see. Allplan bridge layer functionality was very beneficial to us, due to the number of lines a model can have, as seen in the following image. On the left side, variables were generated, while the reference of parametric lines are seen in the central zone. And in this image, we can see too some of the superstructure elements of the bridge. Later, we will show the 3D model and how important was the layer to model this element. Also, we will talk about the variation. On the variation and cross-section tab, we can confirm that each section have different value. This happens because the section is referent to a different axis, as you can see. We have here the expression, and as the bridge axis goes on, it was different value. For this reason, they will have different sections, and something important is that the modeling of the element have different stationing. Some elements start in some stationing, while other elements start with an offset, as you can see on the screen. To finish with this case, we want to show you the result after transferring the Allplan bridge model to Allplan engineering and exporting it to IFC. Of course, with this model we can get the documentation of plan and other data. Other detail, in the model we can see that we also model the contour slope, and so all the superstructure model fit with the 3D model. Now, my colleague Jonathan, we will show you the last case study.
Thank you, Jorge. Finally, I will show some examples about the road and railway bridges. We start with a road bridge. It is made out of a total length of 50 meters with an arrangement of 15, 20, and 15. It also has a constant deck and 2.5% cross slope. This bridge is semi-integral and has a width of 13.4 meters, and it can be seen in the figure that there are some additional elements models, such as the noise barrier. Here I present the model of the superstructure that was used in Allplan Bridge. As you already know, Allplan Bridge allows us to have variables such as longitudinal slopes, offsets, cant, length, or other parametrical values. This led to the possibility of reusing this section to other bridges. So you can see all the variables on the left side. In this cross-section, which was extracted for the model on Allplan, you can see how the cross-slope is modeled in detail. It consists of the deck, sidewalk, pavement, noise barrier, and other elements. Also on screen, I present some isometric views. Here we can see some of these, and on the lower side, there is a plan exported to PDF. Here we can see the animation mode in Allplan engineering, and also the Allplan layout when we export to PDF. And it can also be observe a profile view. Once the model is exported, all the dimensions are yet to be generated. And in the second case, we are going to show the railway bridge that is 126 meters long with a symmetrical arrangement. We will focus on the final result after superstructure was modeled in Allplan Bridge and then imported into Allplan, and how the render and all the sections were taken. So this is the model in Allplan Bridge. And this is the isometrical view of the bridge when we import it to Allplan. Here it is presented the cross section of the deck, as you can see, and how this deck was complemented with the auxiliary elements. As you can see, is a symmetrical box girder. So all the dimensioning were done or was done in Allplan. And finally, we have some profile views. So we have the left and the right side of this bridge. So here you can see the profile view. Continue with the conclusion. We can say that the use of Allplan Bridge allow us to achieve great flexibility in our modeling approach. We could use features such as link girders, parametric axes, smart symbols, while also reusing some of the tools we developed. This led to the generation of link templates, cross-section, and blueprints. We were also able to present symmetrical views, profiles, and cross-sections. And the program had excellent interoperability with EFC format and DWE format, and allow us to generate high quality rendering like the one I'm presenting on screen. So thank you very much for attending to this webinar. Muchas gracias por asistir a esta Präsentation und vielen Dank für Ihre Aufmerksamkeit und wir hoffen, dass diese Referat sehr nützlich für Sie wäre.